Venn diagram is a visual representation of sets and subsets. So when most people think of a Venn diagram, they don't really see this picture, but these are Venn diagrams. This one over here in particular shows a subset. Set A is a subset of set B. Notice it's contained completely inside. So I could give an example. If we go 1 and 2 and 3, you could say set A is a subset of set B, because if you think about it, set B, the circle B inside of it has a 1 and a 2 and a 3. So the set consisting of element 1 is completely contained within the set of 1, 2, and 3. Now the other example shows a complement. A complement, again, means not A. So here we have whatever is in set A, and then out here we have whatever else there is, whatever's not in set A. Picture down at the bottom looks more like what people think of when they think of Venn diagrams, and we'll get to that here in a second. Let's do 5 first. When you see the letter U, it stands for universe when we're talking about sets. And so universe means whatever we're talking about. In a previous example, the universe was the United States. And so we knew there were 50 elements, and that's all we could talk about. We're talking about the states, that's the universe. But here, the universe is the numbers between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The natural numbers. We see set A is 1, 2, 3, 4, 5, and set B is 2, 4, 6, 8, 10. So when you see this question right here, it says not A. So here's the universe. This is all we have to deal with. This is our deck of cards, if you will. But set A is 1, 2, 3, 4, 5. This one's everything else. And so what is there? If there's not 1, 2, 3, 4, 5, we'd have 6, 7, 8, 9, 10. That's not A. So not B. We can see that B is 2, 4, 6, 8, 10. So not B must be 1, 3, 5, 7, 9. This symbol right here, remember, is the empty set. And so this says not the empty set. Or you could think of it as not nothing. If it's not nothing, then it's everything. If it's not the empty set, then it's everything. It's the universe. You can list out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 if you want to, but the easier way is just to call it the universe. This one's a double negative. It says not A. If it's not A, it's just A. So again, you could list it out and say 1, 2, 3, 4, 5, and you'd be right, but I think it's easier to do it this way. Okay, intersection. This is a new symbol. I'm usually going to read it as the word and. So you can see the intersection of A and B, or you might just say A and B. This symbol over here, I would read as or. To me, this kind of looks like a lowercase letter N, and so you can think of it as intersection if you want. This looks like a letter U, so you can think of it as union. You think of union means to join. So quick examples. If this is 1, 2, 3, and I want to talk about the intersection of set A and set B, you'd see that set A has a 1 and a 2 in it, and set B has a 2 and a 3 in it. Whenever I think about the intersection, I think about the word and. Which number is on the left and the right? The only number that fits that bill is the number 2. It's in that intersection. And so again, this is the picture that most people think of when they think of a Venn diagram. It doesn't have to be that picture always, but that's an important one. You'll see that a lot. So let's look at the union of A and B. So let's call 4, 5, 6 right here. Set A has elements 4 and 5. Set B has elements 5 and 6. If you think about this as the word or, I want the number or numbers that are in the left side or the right side, or both. You can write them all. 4, 5, and 6 are all on either the left or the right. And they're all in either set A or set B. Disjoint says the intersection is the empty set. And this is how you draw the picture. It would be like if you had this. We want to do the intersection again, but in this case, set A has an element 7, and set B has an element 8. So if you look at the intersection symbol as the word and, this says which number or numbers are in the left side and the right side. Well, there's nothing. It's empty. There is no intersection. There is no overlap. Number 6. We've got A, B, C, and the universe. Pay attention to the universe. That's pretty important. The universe is from 0 to 10. Natural numbers are I guess, whole numbers from 0 to 10. And it wants to find A intersected with B. I like to write it out. A is 3, 6, 9. We're going to intersect that with B, which is 2, 4, 6, 8. Now, I realize you could probably do this in your head. You look at it and you see which numbers are on the left and the right. The only thing is 6. I'm going to put it in set notation. So I know I left it out of set notation for my work, but your answer is going to be in set notation, 6. It's going to be really tempting for some of you guys to not show your work and not write it down. And what's hard is sometimes you can get away with that, and sometimes that's fine. But other times, like this one, I think it's going to be really hard for you to do without writing anything down. I would not try. I'm always going to write my stuff down, especially if it's a harder problem. Set A is 3, 6, 9. We're going to intersect that with not B. So if you think about not B, well, here's B, 2, 4, 6, 8. So not B is everything else in the universe. Everything else in the universe would be 0 and 1 and 3 and 5 and 7 and 9 and 10. So we're doing an intersection. I'm looking for what numbers are on the left and the right. I see a 3 and a 9. The set of elements 3 and 9. A and C, this is probably one you could do in your head, but we look at A, 3, 6, 9, intersected with C, 7, 10. What numbers are in both sets? Well, nothing is. So that's an empty set. Those are disjoint sets. Now we do OR. For whatever reason, OR is going to be harder than AND. Again, I would recommend you write it out. A was 3, 6, 9. B is 2, 4, 6, 8. We're going to union those together. We're going to join those together. And basically that means write them all. What is on the left or the right? 2, 3, 4, 6, 8, 9. Put it in set notation. A or C, so that's 3, 6, 9. Or C is 7 and 10. So the union, 3, 6, 7, 9, 10. Now, it's not super important that you write them in the right order, but I like to write them in increasing order. I think that just makes sense. Next one, 6F, says A or not A. Think about it. If you're looking at a fruit stand and you're either looking at apples or not apples, you're pretty much looking at everything. That's going to be the universe. A or not A. That's the universe. Number 7, the same type of problem. A or B. There's A. B is 3, 6, 9, 12. Since this is a union, we want to join them. Okay, so we're going to join, and we see a 1 and a 3, a 5, 6, 7, 9, 11, 12. That's the union. Part B is a little bit harder, and students struggle because they don't recognize that this is just an order of operations problem. Parentheses act like they always act. Okay, do that first. Do the parentheses first. So inside parentheses, I see the union of A and B. Well, we just did that, right? the union of A and B from the last problem, 1, 3, 5, 6, 7, 9, 11, 12. We literally just did that one. But what we have to do now is we have to intersect that with not C. And so look up at C. C is 1, 2, 3, 4, 5. And here's my universe. So if it's not 1, 2, 3, 4, 5, everything else would be 0, 6, 7, 8, 9, 10, 11, 12. Notice this is an intersection this time. Intersection means and. I want to look for what's on the left and the right. Let's see. I've got a 6 and a 7. I've got a 9, 11, and 12. 6, 7, 9, 11, 12. 6, 7, 9, 11, 12. That's it. Good luck.